yet. And then we will launch into our week 7. So Corey is there to monitor the chat session. If you have any questions regarding the topic we're talking about, please ask, and Corey will try to answer. Please do not talk about something else like your web project or something which is not related. And then later on we'll have a little interaction when we do problems. So this lecture is going to be theory first, and then we are going to attempt to solve some problems, and that's going to be very useful for you for your quiz preparation. So let me start with sharing the file. So we will start with our week 7 lecture. We'll be talking about scheduling, resources, and costs. That's our week 7. Where are we on our course roadmap? So we've done project networks. That was last time. And now, when we finish scheduling, resources, and costs, we're going to finish with the planning section. So you can see how long we have been covering this initiation and planning stages. So we are at the week 7, we are almost halfway there, and we are still in the planning stages. So planning is very important. You have to have reliable inputs, you have to have reliable numbers, reliable budget, schedule, everything. Why? Because the monitoring and controlling of your project becomes meaningful only if you have a reliable baseline. And baseline is the term we're going to mention tonight quite a lot, so please remember it. So what we developed last time was a project network. We thought about dependencies, we thought about physical and technological constraints, about logic, how to organize our activities. But did we develop full schedule? No, we did not. We developed only part of that schedule. So only when we load resources and when we load cost, we will have a full schedule, and then we will get the master plan, which is the output of our planning stage, and we can move forward. So let's see why and how that is done. So previously, last week, we scheduled activities. We organized activities in a logical order. We considered technological dependencies, we considered physical constraints, and we developed an order of activities happening in the project. Yes, we did get the approximate or probable day of the end of the project, but only based on logical dependencies or an organization of these activities in the network. Do we have the full schedule? Do we have the duration of our project? I wouldn't say so, because what project managers have to ask after they develop this project network, this is AON that we talked about last week. Project managers, good project managers, and you will be good project managers after you complete this course, they have to ask certain questions. And the first and most important question is, are we going to have enough available resources at a time when they are needed? Are we going to hire some external help? Are we going to hire consultants? Is there anything that's unforeseen dependencies? And is our duration of our project from the Gantt chart or AON, is it realistic? In most cases, research shows us it's not. And there is this particular study that's mentioned in your textbook that says that over 50% of projects, when resources are added, there is an increase in project duration on an average by 38%. So it's very important to ask the question about resources, especially in the multi-project environment where resources are shared by multiple projects. But we'll see how that is done when we go further. I mentioned after we finish this lecture and after we load resources and budget in our schedule, we will get a project baseline, which is called also a master plan. So what is a baseline? Baseline is a reference point. So you have to have a good input, you have to do good enough planning. Obviously, you don't overdo that because everything that you do costs money. So you have to do an optimal amount of planning. And I'm sure Corey talked about this when you started planning stages. You cannot do too little and you cannot do too much. But also the quality of your planning is what matters. So once when you produce this bottom line, this reference point, which is called also a baseline, then you can compare. Like in the later stages of your project life cycles, you will see what's happening. You will see what's going to happen actually in the project. And then that figure, that data point from the actual happening in the project, you will compare to your baseline that you delivered in your planning stages. And then you can say how your project is going. But there is lots of references. So there is not only one. You've got a scope baseline. And where do we derive a scope baseline from? We get it from our WBS. That's how we started, remember, in this planning stage. Then we have a schedule baseline, and that's basically what we did last time, and a bit that we are going to do today with our resources. So we have activities in a logical order, sequences, technological and logical dependencies, plus resources added on top of that. And then we get a schedule baseline. And then we also have to have a cost budget baseline. And that is done by time phasing the budget. So you, and I mentioned that last time, you roll your budget over the time frame. So you join two dimensions, time and cost. And only then you can compare apples and apples. So there are three baselines, and all three you're using throughout monitoring and controlling of your project. Okay, so we mentioned that after you develop a schedule, after you know the dependencies of your activities, you have to ask questions. You cannot assume that resources will be enough. You have to check that. You have to. Every activity has got resources allocated, and for every activity and a sequence of activity, you have to see: are you going to have? Are you going to have enough? And you have to make judgment. Also, if you have more projects, that's even a more complex task: how to distribute these resources. And also, in the WBS, actually, in your work package, you also have cost estimates. So WBS, it's your scope baseline, bottom line is work package. In a work package, you've got activities, and you've got all these costs listed, whether it's a labor, material, equipment cost, and then you can roll it up. But is that a budget of a project? No, it's not, and we will see why it's not. We'll try to explain this tonight in this lesson. So here is an example for you. You haven't heard this lesson, but look, there is lots of project managers out there that still haven't done this, and they're still doing it wrongly. And I'll give you a perfect example. So the project is to create a market report. It has to be done within 12 weeks, and the cost is $40,000. So what managers do, they usually divide this cost over 12 weeks. It's not done like that, but in their minds, that's how they do it. And then they compare actual, what's really happening, how much money do you pay in each week. So in this particular project, a project manager had to allocate $9,000 at the end of the second week. And the question is, are we under budget, on budget, or over budget? Project managers, unfortunately, some of them still work with this simple maths calculation. Some things might seem obvious and logical to you, but actually they do not conform with the theory. So you have to know theory and these strict processes that are developed in project management to be able to manage your project. And something I would like to make a little digression here, and I'd like to mention, because I've noticed throughout webinars and throughout consultations while you have been doing project 2, that most of you are still not clear on what's a project and how project operates and what's a day-to-day operational business. So in OBS, many of you, even though I've mentioned this, have a financial officer or a CEO or these people, this organizational breakdown structure that works in operational day-to-day environment. You have to distinguish breakdown structure and the responsibilities in the project are not the same. In operational business, you've got repeating work, and you've got departments that deal with this repeating work, and they're in charge of it. In a project manager is in charge. He's in charge of budget, he's in charge of schedule, he's in charge of performance. So there is no financial officer or director that is in charge of that. Yes, he's submitting his report to a higher management, but only as a report. He is responsible for budget. So that's just a little digression. You still have to clear up the difference between project and operational business. So, okay, where are we at? On budget and over budget. And if you multiply, do this simple maths, 2 weeks times $3,333 per week that we calculated we're going to spend per week, it gives us a value of $6,667, and we've spent $9,000. Not listening to this lecture, most of you would say we are over budget. You simply deduct 9,000 minus 6,667, and you get over budget 2,333. It's not like that. It's not this simple math, and it doesn't work like that. You cannot say if you're over, on, or under budget until you time phase your budget. So you have to bring your money on a time scale, and you have to join 2 dimensions. And we'll see how that is done. So what is the time phase? You can think in terms of the moon, how moon goes through phases, time phases. So we've got the new moon, and then you go through these waxing crescents or whatever, if you follow that, and then you get to the full moon. So that's basically a time phase, something that is spread over time on a time scale. That is what is called a time phase. And what's the time scale in our case? That's the duration of our project. So that's the 1 ASICs that we work with. And that's the duration of the whole project. So You have to think, you know, the life cycles of the project. You have to control and monitor throughout the whole stages. But where does control and monitoring happens the most? It happens in these executing stages, where you compare whatever you delivered in the planning stage. You compare what's delivered in your master plan. And every time you assess risks, and every time you go back and make changes if they are necessary, because you have to perform the best you can. So you cannot let it go. When you compare what's happening to your master plan and you realize you're not doing well, are you going to just leave it and report we're not doing well? Like, I've had some questions with your projects, and you realize something has gone wrong, and then you ask, can we make changes in the schedule? Can we amend our WBS even though we are further down? Yes, you can. Yes, you can. There will be risk associated, but you have to do changes. Otherwise, everything will be wrong. At least you've got a chance to fix something, to get back on track. Maybe not fully, but to some degree, you will be able to get back on track. But change management in a project is a whole new area, and something that has to be studied and implemented properly, because you have to do it very, very carefully. But we're not going to talk about that now. So in project, you've got, when we talk about a schedule, obviously, we can talk about various constraints. So it can be technical or technological and logical constraints. And we've seen that when we developed AON, when we organize our activities in the sequences, in a logical order, what did we consider? We considered technological constraints. But what else do we consider? We consider physical constraints. Sometimes simply you cannot organize activities in parallel because of conditions that they are done in. You cannot. You don't have physical space to do that. And then something that we haven't thought about last time when we developed AON and Gantt chart, we haven't considered resource constraints. What about absences? What about shortages? What about some unique interrelationships, interaction of resources? They might require special sequences. Anyway, these resources, when you match your AON with your resources availabilities, you will get completely different sequencing. So you will get a different network, and on many occasions you will get a different duration of your project. So what did we have? Before? So we considered technological constraints and dependencies and logical order. And then we arranged our activities. Sorry, I'll just take a pen here. We arranged these activities in this logical order in a sequence. So activities can be organized in a sequence, we've seen that, or they can be organized in parallel. Okay, this is just when you consider activities without adding resources. So, for example, this is your simple wedding planning network. And you can see that these three activities, purchasing refreshments, decorate hall, hire a band, they can be done in parallel. Yeah, okay, so yes, maybe you can do it even in one day. But what about, so you develop this in this logical order, considering technical, logical constraints, physical constraints. There is no physical constraints here. Purchase refreshments, decorate hall, hire a band, there is no physical constraints. So you are allowed to put that in parallel. and this is going to be the end of your project, the finishing date of your project, let's say 20 days. However, then you consider who is going to do your work. And if there is no one else who is going to do it but you, so only one person, and you have to do these 3 in one day, can you do it? Can you manage that? Can one person manage to do all 3 in parallel in one day? No, you cannot. So if there is only one of you and no one else wants to help you, no bridesmaids there, and no future husband, how it usually happens, what do you have to do? You have to split it. You have to reorganize your activities in a sequence. So what's going to happen? Look at this. Your project is pushed further in time, and it's not going to finish at 20 days anymore. It's going to finish at 30 days, for example. I'm just imagining. So you can see how resource constraints in most cases actually will push the end date of our project further in time. So that's why I was saying, when you organize activities in a network, you get this end date, but is this really the duration of your project? You don't know that until you load your resources and assess availability of your resources. So what is here important, that resource dependency always takes priority, but it never violates technological dependency and logical order. And we will see that on the examples, and I'll tell you what I meant by this. So we talk about resources, but what are the resources? So there are 3 types of resources. There is people, obviously. People deliver work, people input efforts, and as a project manager, you are actually matching people and their skills to appropriate tasks. This is a very complex area of managing people. But once again, I will mention that difference between operational business and project manager, just to clear that up in your mind. So there is no HR department. Okay, HR department is in charge of something else, but direct management of people is who is in charge. It's project manager is in charge of people working on the project. So I wouldn't like to see HR departments in your OBS and an intersection with WBS. It doesn't work like that. Please distinguish. That's really different. Materials. What can be materials? Materials can be a lot of things. It's not just a concrete or cement or railway that you're delivering. It can be, for example, survey data for your marketing project. That's also materials. And if materials have to be delivered at a certain point of time, so you've got a very narrow window, and you have to deliver it in a certain point of time, you're dealing with a lean project management. So if you covered lean management and Six Sigma and all of that, you'll know what it is. That applies to project management as well. And if the cost of this material, so it's very important when you deliver it, and the cost is significant, then you will load that as well, and you will consider these resources. In any case, you will consider it, especially you'll pay attention to these important ones. And equipment, we had an example last week when I talked about hammock activities, and I was explaining about how cranes are scarce resource, and they have to be booked in advance. There is lots of money that has to be committed to this equipment. So sometimes you will show it even in your network because it's that important. But it's a resource that has to be considered, and sometimes that resource can delay a project if it's not available, if it's not managed properly. The same applies for materials. If it's not managed properly in your schedule, it can become critical. So you can organize everything. You can organize your activities. You can organize your people. But if material or equipment is critical for some task or some activity, and you haven't managed it, then you will experience delays. So all of that has to be considered when you do this resource loading and scheduling. So in a scheduling, whenever project managers, again, I'm reiterating project managers, they can have a scheduler. So that's a different certificate that you can obtain from a PMI office. So on a big project, you will have a specialist, a scheduler. But a scheduler is only recording. He is dealing with Microsoft MS Project, with scheduling tasks. But who is in charge of a schedule? Project manager. So once again, project manager is in charge of that. So when a project manager he's supposed to do scheduling, first thing he needs to establish is the type of a project. So is the project time constrained, or is the project resource constrained? What does mean time constrained project? That means project has to finish at a certain date. So that's constrained, that is fixed, and that cannot give. If something cannot give, if something is fixed and constrained, then something else has to give. And what is that? That's resources. So in these types of projects, you have to be available to add more resources if you're running late because your date is fixed. It's just like that. And in a planning stages, when you're talking to your superiors and when you're delivering this schedule, if by nature of the project your time is constrained, you have to make sure that you will have flexible resources. So if need being, you have to be able to add more resources on the project, or more critical resources, or more specialists, or outsources. So you will have money, additional budget to do something more just to meet the date of your project. And then you have another option, another possibility. That's a resource constrained project. So you cannot add more. What you get is what you have to deal with. You cannot change it. And in this case, another dimension has to give. What is that dimension? That's a time. Not necessarily if you're resource constrained that your time will extend, but research suggests, practice suggests that in most cases it will be extended. So resources are fixed and time is flexible. So if something is fixed, the other dimension has to be flexible. So we are going to do now resource allocation, and we'll cover that by examples. That's the best thing, that's the best way to learn. However, we're going to start with the limiting assumptions. Look, these assumptions are just to explain the procedure of resource allocation. They do not happen in real life. But for this purpose of learning and explaining these two types of resource allocation, we're going to have the following assumptions. Firstly, splitting activities is not allowed. In real life, it is, and we'll touch base that a little bit later on. It's not recommended, but we are going to start with this. Why? Because we're doing this work manually. And if you add another dimension, that's splitting activities, or another assumption is changing the level of resources per activity, then you will get a multiple dimension problem that you're not going to be able to solve manually. And even for software, that's going to be very problematic. And then we also have a risk assumptions that activities with the least slack possess the least risk. Well, is that like that in real life? That's how software would see it. Software thinks that the activity with the most slack possesses the least risk. But in real life, we're not machines, we're project managers. We have to assess the nature of the activity and really see what's the risk of that activity. But for the purposes of this resource allocation, we're going to assume this is true. We're also going to assume that if we reduce flexibility of the project, that does not increase risk. Is that correct? Well, think about it. Firstly, what is a reduction of flexibility? It can be many things, but the most obvious one is when you reduce slack in your project. You know how some activities have got slack, and we talked about total slack, and we talked about free slack. Every time you reduce it, you're actually increasing risk. Why? Because you're creating more near critical parts or more critical parts or more critical activities. So sensitivity of your project changes. You are getting more and more sensitive project. More sensitive project, does not increase risk? Is that true? No, but this is an assumption. We have to start with assumptions to simplify our manual work because we're learning about resource allocation. And the nature of activity does not increase risk. Obviously, I mentioned before, we have to examine nature of activities. Every time you do changes, every time you have to consider where to reduce slack, where to move each activity. Next time you'll be talking about reducing project duration. Whenever you do changes on activities, whether it's in time, it's in duration, or anything else you're doing with it, it does increase risk, and you have to consider nature of that activity. So is it going to be this one or that one? In your problems, computational problems, it does not matter. But in real projects, you will know nature of activities, and then that will be another dimension that you'll have to assess. So resource allocation methods, we've got resource smoothing, and that is for time-constrained projects. So that's a smoothing technique that is doing leveling of your resources, that's doing utilizing your resources. So you're managing your resources to achieve within that time frame, because time frame is fixed, remember. And then you have a resource constraint scheduling, where duration of the project may be increased if some activities cannot achieve it, they don't have adequate resources. But we'll cover both examples and we'll see how that's done. And the first example is on time-constrained projects. Once again, time constraint, time is fixed, the duration of our project is fixed, you cannot change it. You have to complete it within that day. And what do we use then? We have available resources. Okay, so that's flexible. But does that mean we can splash and spurge and we can allow things to happen in any order? Like I had a project where one construction manager was put, to be working 2 years before construction started, and the explanation was, well, they're not readily available. So he was just doing his times for 2 years, and he was getting paid huge money. So that's not good. I wasn't a project manager, by the way, on that project, but anyway, we learn a lot from. It's better to learn from others' mistakes, but we also have to learn from our mistakes, and that's how good project managers are shaped. So we need to manage it well. We have to balance it. What do we balance? We balance peaks and troughs. We balance these fluctuations. We balance that we're trying to reduce also the overall number of resources needed for the duration of the project. And to explain that, we will use this example of a botanical garden project. So the project is to complete a new garden within a botanical garden, not a whole botanical garden. And for this purpose, we use an equipment. Okay, so that's a resource that we have to schedule. So what equipment you use? We use backhoes. If you don't know what a backhoe, that's this little yellow beauty that's very versatile and in projects, similar construction projects like that. So this example is assumed to be time constrained, and all backhoes are interchangeable. Okay. So what do we have here? So our limit in our project, I don't think it says here, we've got the limit of 3 backhoes, okay, at one time. And this is our network. This is activities, so design, layout, then we have lightning, we've got irrigation, fence, etc. So we've got 6 planting. Okay, this is walkways, irrigation, fence, lighting, and plant. We've got these activities that are given in our AO network. So we've got the dependencies, and we've got the sequential logical order, and hopefully you practice this AON at home. We said it's you have to do it. So these are the exercises behind your chapter 6. They are easy, they're not that difficult, but you have to be able, and I'm repeating this again, to do it quickly because of the time limit in your quiz. You have to be able to perform quickly forward pass and backward pass to calculate your slack and to identify your critical path, because your critical path is your starting point whenever you have a network. We've seen in PERT analysis, we always dealt with critical activities. So unless you know how to identify critical activities and your critical path, you're not going to be able to move further. And the same applies with everything in terms of computational problems. There is plenty in your book. We're going to cover some examples, but you have to practice at home. It's not enough just to listen and say, this is easy, I know to do that, because you have to have practice in your head. So, okay, slack is 0 on activities 1, 3, actually, design, layout, walkways. This is walkways, lighting, and planting. And this is our critical path. And then here we've got a Gantt chart, a little bit blurry, but you can see these activities from AON. And what is a Gantt chart? We said it's activities, duration of activities is presented as these horizontal boxes. They present duration, so activities are presented on the time frame. So this is 2-dimensional graph where these vertical lines connect one activity to another activity. So see, in Gantt chart, you don't have critical path. You don't have organization of activities like here, but you have one connecting to another. You've got these vertical lines, and that's why we said in a Gantt chart you've got a free slack. You don't see a total slack because you don't see the critical path. So this activity layout doesn't have any slack. Walkways doesn't have any slack, but see here, irrigation and fencing, both activities that last from period 4 to period 10, that's 6 time units. Okay, so irrigation this is duration, 6 time units, and fencing duration is 6 time units. They both have a slack of another 6 time units. And where do we read slack? We read it here. Okay, So this is our network and our Gantt chart, or a schedule without resource loading. So what do we have to do now? We have to make changes and adjustments considering our equipment, which is our resource, and that's a backhoe, and then move it, adjust it, utilize it, level it, do whatever you need to have a proper management of your resources. Sorry, there is no limit in resources in this example. Am I wrong? So there is no limit, but you have to utilize it well. So this is time constrained project. It has to finish at these 24 time units. You can see it here in the Gantt chart on a time scale, or you can see it here in your end activity, in your AON. So what do we have here? Okay, one backhoe needed for walkways, one backhoe for irrigation, one for fence. Then again, here in the period 10 to 16, there is only one backhoe for the lighting. And in the period 3 to 24, there is 3 backhoes needed for the planting. So how do we show our resources? Okay, resources loading on a time scale. This is how we read it. So we've got this information, we've got the Gantt chart, activities duration, we've got the number of resources, and we just load it per time period. So layout is starting period 1, ending period 4, requires 2 backhoes, okay? Starting period 1, ending period 4, requires 2 backhoes. And then we have this critical period 4 to 10. You've got 1 backhoe here, 1 backhoe here, 2 backhoes there, so 1, 1, 1. We've got 4 that are needed from period 4 to 10. Then we go down to 1 from period 10 to 16. And then we jump again because this activity requires 3 backhoes. From 16 to 24, we need 3. So obviously, we've got several problems that we have to deal with. We've got fluctuation, okay? So you can see how it goes, okay? Fluctuation is not good because it's not, what do you have to do? Think in terms of practical application of this equipment management. You have to have 4 backhoes on the site. And then after week 10, you have to remove 3 of them. And moving backhoes and taking it off site and then bringing it back on site, it's not a simple task. Firstly, it's disruptive for a project. Secondly, it costs money. So everything that costs money, wherever there is a possibility to reduce that by proper management, you have to do it. And that's what we're going to do here. And then also we have peaks, like here. We need 4 in total. 4 in total. Can we reduce that? We will see if we can reduce that. Okay, so that's the number of resources over the lifespan, fluctuation, and the peak. We've got 3 problems here. What can we do? Okay, let me just erase this, what I've done here. We can utilize Slack. So every time that you deal with time-constrained projects, you have to assess activities that have a Slack. Okay, so these activities, irrigation, fencing, they've got 6 times units Slack. We can play with them. We can move them. We're not going to affect the end of the project. We're not going to affect the next activity and resource that activity uses as well. So we can move them and maybe level them. So both of them have this slack of 6 time units. 6 and 6, okay. However, if we move this irrigation here, then we'll have 2, 3, 2, 3. So what are we going to have? Fluctuation. However, if we move this fencing activity, and use up all this slack of 6 time units, then what's going to happen? Okay, 2 are going to be moved here. Okay, and this is our resource loading chart. What did we have before? We had fluctuations. Do we have fluctuations now? No, we don't. We have 2 up to unit 10, and then we jump to 3. So this is not hard. You are bringing at week 1 2 backhoes, then you run for 9 further weeks, and then you bring 1 more. So there is only a jump of more, and then you run with them until the end of your project, which is fixed, which is 24 weeks or time units, whatever your time units is. I'll presume weeks. What else did we avoid? We avoided this peak in our requirements. Remember, previously it was 4 backhoes, and that was the maximum. That was peak, and especially peak is somewhere in the middle of your project. And then we reduced it. What is the maximum number of backhoes? It's 3 now. That's a significant reduction, isn't it? It's 25%, considering that previously we had 4, now we reduced to 3. And that's a significant amount of money. Maybe when you look at numbers, 4 to 3 doesn't mean anything. But when you look at the numbers in thousands and thousands of dollars, that's significant. And that's why it's way better to present it as in percentages. Okay, and so resources over the life of the project have been reduced, fluctuations have been reduced, and we don't have that peak in our project. So you may assume that this is a difficult task to do when you have a complex project. Yes, you're right. This is manually very intensive to load and manage and move your resources and utilize it properly. But hopefully, luckily we have these computer software programs that deal with that. They can do that automatically. However, how they work on assumptions that we previously stated. They don't assume risk. They don't assume any nature of the activity because they can't know nature of activity. So whenever they give you data, you don't use that data just like that. You have to look at data. You have to make adjustments. So it's easy when you are given this sheet of reductions or changes that the software makes, and then you assess nature, then you assess risk. You've got the majority of work done. So you don't have to do it manually, but you still have to manage. Remember, softwares do not manage project. We are the ones that, the project managers are the ones that manage projects. Okay. So what do we have now? We have a new network diagram. Why? Because we moved this activity, lighting activity, we used up all its slack. So remember, not lighting, sorry, fencing. Previously, this activity had a slack of 6, and now this slack has been reduced to 0. So we used up this slack and we created what? We created another critical activity. So this is now a critical activity. And we created another critical part. So instead of 1 critical part, we've got 2 critical parts now. Obviously, we increased sensitivity of this network, and as we can see, there are advantages and disadvantages. Advantages we covered: peak, fluctuation, overall number of resources, utilization, saving money, proper management of your resources. Yes, that's correct. But there's some disadvantages. You're reducing flexibility of your network, and we said that at the beginning of this lesson. When you're reducing slack, you're reducing flexibility, you are increasing risk. Every time your sensitivity rises, your risk will rise, and you have to assess your risk. And that's why you're looking at the nature of your activities, because you are increasing criticality, number of critical activities, number of critical parts. So once when you load your resources in your network, you notice in this particular example we had a slight change, which is one Slack and one other critical activity. But changes can be different. Your network can actually look completely different. And then you may get these parts that are where critical parts actually don't make sense anymore because the sequence of activities is broken, and some activities can even be left dangling. So what I suggest to all of you to read, it's a very, very well explained and a useful part of your textbook that talks about critical chain activities. So when you deal with activities only and their logical order, you talk about critical parts. But once when you add resources and make changes, resources make changes, loading resources make changes on your network, on your path, on your dependencies, then you don't look at a critical part anymore. You look at a critical chain because you've got two critical dimensions now. And there's one practitioner scientist as well, Eliyahu Goldat, that dealt with the theory of constraints, and he was the first one that developed this term, a critical chain approach. So once again, it will be really useful and interesting for you to review this appendix 8.1. So we've covered time constrained projects. And the next one, the next example is going to be resource constrained projects. But at this point of time, just before we move on to another scheduling possibility, I'd like to make a break. So you can, the break will be until 7 p.m. So I'll just turn off, or actually I'll leave this chart, but yeah, so until 7 p.m. there is a break. Okay, we are back to the second part of this lecture. In the first part, we covered time constraint projects, and now we're going to talk about resource constraint projects. Remember, project manager, when he's doing scheduling, has to decide, consider the nature of the project. Is it time constrained with the fixed time factor, fixed finish date of the project, where resources are flexible, or is this resource constraint where resources are fixed, you only have a limited number of resources? Something has to give. When one dimension is fixed, something has to be relaxed. And in resource constraint projects, time is relaxed. It doesn't mean that we can take as much time as possible. Just like we've seen in the previous example, resources are relaxed, time is fixed. But does it mean that we can use as many resources as we want? No, we have to utilize them, we have to level them, we have to be mindful of budget cost. So that's a project management. You manage every aspect of the project. And the same applies with the resource constrained projects. Time will give. In most cases, it will give, but you cannot extend it to a maximum. You have to make an optimal duration considering these limited resources. So what do you do then? What do you do? You have to allocate your resources to priorities, to priority activities. And can you do that manually? No, most probably you cannot. In some cases you can, but softwares are there to deal with that, and you can do it by optimization. However, even linear programming and different kinds of optimization, when you have tens of thousands of activities in your network where you have to allocate resources, it's not just a number of activities, it's a number of other factors, available resources, risk, and etc. Putting that into software, optimization software, it's firstly not practical, and secondly, it takes time. It's very complex, and whatever takes time and it's complex, what's going to be the end result? It's going to cost money. So you don't consider that in most projects. So even moderate size project, you will use heuristics. And what is heuristics? It's a rule of thumb, and they can be different. You apply different rules. It can be minimum slack, first one first, the most critical one, the one with the most critical followers, the one with the most subsequent activities, the shortest one first. It can be a number of heuristics given. So I'd like you to remember this. Just because we are working with one set of heuristics, it's not that every time in every project this set will apply. So you have to check what is your heuristic, what is your rule of thumb, or what is your set of rules of thumb. So in this example in our textbook, we are dealing with a parallel method. Why parallel method? Because we've got a set of heuristics that's applied in parallel. It's an iterative process, so we apply one rule. If that rule is satisfied by more than one, then you apply the second set of rule. If that set of rule is satisfied by more than one, then you apply the third set of rule, and that's usually enough. That's why we've got three, and that's why it's called parallel method. So remember, this is an iterative method. You do it step by step, and every time you make changes, after each step you record these changes, and be diligent in recording, otherwise you might miss something. Similar thing will happen in reducing project duration. Every time you make changes, you do new calculations, you calculate new critical paths. So it's an iterative process. Do not skip it. Do not do it in your mind. Do it properly. And what does that mean? I'll show you on the example. So this is a software project, and this is to create a new software application, but we only have 3 programmers, not more. So our resources are limited. Last time we had as many as possible, but we had to manage them well. We had to utilize them. This time we don't have as many as possible. We have only 3, and that's why it's a resource constrained project. So how do we deal with that? That's our network. Okay, so these are our activities that are done in the network, and you can immediately identify critical path with 0 slack. So that's 1, 3, 6, 7. We've got several parts. We've got this part, we've got critical part, and we've got this part. But we are interested in a critical part, and you always have to be able to quickly determine what is a critical part and what are our critical activities. Okay, so what do we do next? Okay, we load resources on a time scale. Remember previously we loaded duration of each activity on a time scale to get a Gantt chart. We still do that. We still have all this data. Activity on a vertical ASIC, so remember that's the basics of our Gantt chart, and a time frame. Which time frame? That's duration of our project. That's 14 weeks. That's basically a Gantt chart, but a modified Gantt chart, because now we're also loading resources. So all information is given here in these vertical ASICs, vertical columns, sorry. So duration of activity 1 is 2. So what do we do? Duration is 2. So this is a horizontal bar. That's duration of activity 1. But we also load resources. And resources are given here. They're also given in our previous slide. See here, 2 programmers are needed for activity 1. So basically, we copy all this data from the network and we put it here, so we can easily develop it. Please don't scribble on my slides. Let me just see. Okay, I'll just delete this. Sorry. Okay. Yeah. Fine. Okay, so you're loading time, but you're also loading number of resources. And remember our assumptions. We had assumption you cannot split activities, so they have to run in continuation, and you cannot change resource requirement for activity. So this is 2 programmers, and that's why I put 2 and 2 here. Okay, we do the same for the rest of the activities. Activity 2, I'll just do 1 more, and then we'll move forward. Activity 2, duration is 6. Slack is 2. Okay, here slack was 0, so that's why we don't have these little empty boxes. Nothing hanging out here, so that's a slack of 0. And we have 2 programmers. Okay, so duration is 6. 1, 2, 3, 4, 5, 6. You put application like usage of 2 programmers for 6 time units. This bar here is empty. You still show it shaded because it's representing slack. So that's a possibility to move this equipment, to move your resources. So you might not have resource here. You might have resource there. Okay. But for the time being, you're loading your resources only for the duration of your activity, but you still show the slack of this activity. Activity 3 does not have slack. It's using 2 programmers, duration 4. This activity 4 has got a long slack, 6 units and time units, and 1 programmer is only needed here. Well, that's really pretty flexible. Okay. 5, duration is 2, 1 program is needed, 2 is slack. So I don't have to read it from here. Obviously, I have to read it when I develop it, and you have to reference it all the time. But I can see what is happening from this chart, time scale chart. You're loading resources in our schedule over the time frame. So 6th activity, no Slack, 1 programmer used, duration is 4, easy to read. Okay, now we have loaded resources over time frame. So that's very important in order to get a schedule, in order to get our baseline. But we have to add them all up by time period. So that's important. So we look at the periods from 0 to 1, from 1 to 2, etc., etc. So each time period is looked at individually. And this is the end, current end of our project, week 12. And see how many we've got. So by column, going vertically, we are adding them all up. 2 is period 0 to 1. We put 2 programmers. 2 is here. However, situation is a little bit dire here, like 2 to 3, 2, 2 and 1, it's 5 programmers. 5 programmers, 2 and 2, 4 programmers, 4 programmers, 2, 1, 1, 4, 2, 1, 1, 4, okay? What are we looking at? We're looking for this limit of 3 programmers. So look, for the most of the duration of the project, I would say this is executing life cycle of your project. That's probably when you need the most. For most duration of your project, from period 2 to 8, what do you have? You have more need for more resources than what is available. What is available? 3 is available. Okay, 5 is bigger than 3, 4 is bigger than 3. These parts are fine, these parts are fine. But can we run the project like that? You've got a schedule, but now you loaded your resources in your schedule over a time frame. That's what's important. So time phased loading of resources. Remember our moon? Now we see we cannot run project like that. So we have to make adjustments. What is flexible in this instance? Time is flexible, but how are we going to do it? We're going to do it step by step, and we are going to apply priorities by heuristics. And what are our heuristics that we are working with? First one is minimum slack. Second one is smallest duration. And the third one is the lowest ID. Once again, it doesn't have to be like that. It's not in every project on earth that you're going to use that. It's for our example in our textbook. Your project might have different heuristics depending on the nature of the project, depending how you assess the risk. So different ways. Remember, this is not one and only set way of loading resources and giving priorities, but we are going to do by that rule. And when you get your problems, when you deal with your problems, please check heuristics. Heuristics have to be given to you. Don't assume what heuristics are. If they're not given to you, then you try to work out what's the optimal schedule. Look, heuristics will never give you the best schedule. But considering time and effort that you have to invest, it will give you a pretty good schedule. But doesn't mean that once when you apply your heuristics that it's going to be the best possible. Maybe you have to change the order of something. You have to maybe try something else to see and check if you're going to get a little bit better one. So it's not set in stone. Even if you decide what your set of heuristics is going to be, you may try something else, just a little bit of twiddling, and you might get something else. And we'll cover one example like that. So now we have to apply our heuristics and load our activities, giving them priorities. So what activity is going to be given priority? Minimum slack first, small duration second, and the smallest ID number that's a parallel set of rules. Okay, so in the first two periods, we don't have a problem. We only use two programmers, so that is fine. Okay, but in the third period, so we do it period by period, from 2 to 3, what is eligible to be scheduled? It's activity 2, it's activity 3, and activity 4. Okay, what is our first rule? Our first rule is a minimum slack first. Okay, what is the slack here? 2 is the slack for activity 2. Okay, I'll just go to previous one. So 2 is the slack here, 6 is the slack there, and 0. And this is the slack for activity 3. So obviously we're going to load activity 3. We're going to give this activity priority. So we can use resources, and this activity will have priority, and it can start on this day period 2. Okay, loading it, putting 2, Y, duration is 4, slack is 0, so 1 is loaded and 3 is loaded. Okay, what's going to be the next one? Okay, we can assess activity 2 and activity 4. Yes, activity 2 has got a smaller slack. It's got a slack of 2, while activity 4 has got a slack of 6. But we cannot load it. We cannot give priority to this activity 2. Why? Because this one has been loaded. And activity 2 is using 2 programmers. So we will immediately be over our limit of 3 programmers. So we cannot consider it. So what do we have to do? We have to push it further in time. Every time you push it further in time, you have to put this cross. Okay, and that's why we're putting cross. And remember, you do it time by time. And that's why we are considering only this period 2 to 3. Okay, so if we're not considering activity 2, then what does this mean? We can load activity 4. So we are loading it 1 and 1. Okay, we reached maximum of 3 programmers, and we'll reach maximum 3 programmers here. Okay, so we put cross here, and every time we delay it, we push it further in time, we have to change all these data. So our early start time is not going to be 2 anymore. So we know definitely we're not starting at this period of time 2. So that's why we make a cross, and we put number 3 here. Okay, our slack, it's going to be not 2 anymore. We have eaten 1 period of time. So we reduce it. We know it's not 2 anymore. We put 1. So this is important to record all your changes as they go. Okay, so this is what we've done already. So we loaded activity 4 with duration 2, slack of 6. We loaded activity 3. We pushed this activity 2 back in back 1 by 1. Okay, so what is next? We're examining this period 3 to 4. Let me do it here. Okay, 3 to 4. Can we load activity 2 here? No, because it's going to exceed. So we have to put cross here. And what do we do? Early start is not 3, it's 4 now. Slack is not 1, it's 0 now. Can we load it in period 4 to 5? Okay, it's using 2 programmers. Can we put 2 here? 2 plus 2 is 4. It's bigger than 3. 3 is our requirement. Okay, that's the maximum number of programmers. Remember, okay, that is our limitation. Sorry. So you cannot put 2 here because 4 is bigger than 3. So you have to put cross. We did put cross. We pushed it back in time. You change early start. So now it's at least 5. Maybe it's not definitely 5, but it's at least 5 considering this time point. And the slack is not 0, it's -1. Can we do it here? 2 plus 2? Again, the same situation. No, put a cross. Okay? So early start is not 5, it's 6. Slack is not 1, it's -2. And we put a cross here. So this is the first period of time where we can load activity 2. Activity 2 needs 2 programmers. It lasts for 6 time units, so you load 2, 2, 2, 2, 2, 2. Okay, what's happening? We pushed it back in time. So our early start is now 6, okay? And that's been recorded by your little crosses. And your slack is -2, okay? Previously, we had all this slack. But now we've gone beyond. So that's why it's -2. What does that tell you? What does this tell you? Okay? Can someone tell me in a chat box? Okay? We've got this slack -2, and you can see it on the bar chart. What is happening? What's going to be the consequence of it? You know immediately. Yes, Alex, it's a delay in project deadline, so a time frame will be pushed. Okay, the end of our project, yes, by at least 2 days. This is our examination so far. So by now we already know our project will be pushed in time. Okay, so now we continue. Okay, what is the next one? So we loaded 1, 2, 3, and 4. The next ones to be that are eligible to be loaded. Okay, I'll just go in here. Is this loaded? Okay, yeah. So the next one to be loaded are either activities 5 or activities 6. And activity, this is not clear, okay, activity 6 has got a slack of 0, and activity 5, it's probably better to read here, activity 5 has got a slack of 2. So applying the first set of rule, minimum slack gets priority. So we give them their resources and we can load them. They can start, they can get a priority for the fighting over resources because there is a shortage of resources. So that's their priority. So, okay, has this been loaded? No, it's better to look at here. Okay, so this 6, we also have to check how many resources it's using. It's 1 programmer, and here we've got 2 previously loaded, so that's fine. We can load 1 programmer, duration is 4. So 1, 1, 1, 1, slack is 0, fine. So we'll add it up by columns, remember, because we are examining by weeks. We're only looking at this time frame, 6 to 7. You go down and see what resources are needed in this time frame. Okay, go down, add it all up. So 2 plus 1. 2 plus 1 is 3. We haven't gone beyond resources available. This is free. Okay, this is fixed. That's why we got 3 here. Okay, we load this and this is fine, but we reached maximum. We cannot have any more there. What does that mean? It means we cannot load activity 5. Okay, for how long? We cannot load it as long as we have these 3 programmers reached. So we put cross, 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 4 times cross. Every time you put cross, you have to change your early start. So previously, early start was here. This is this shaded box, 6. We cross 6 to add 7. We cross 7 to add 8. We cross 8 to add 9. And finally, we end up with 10 because 4 times we move this activity. 4 time units. Okay, so that's why 4 times we change early start, 4 times we change late finish, and the most important thing, 4 times we change this slack. So slack is not 2. Previously, you had 2 time unit slack, but you have -2, okay? So you load it here, 1 and 1, and again, you add up. You have to check every time unit after every loading to see if you reach the maximum. And by adding up by columns, 2 plus 1 gives you 3, and 3 you are at a maximum. So the next eligible one is the activity 7. That means you cannot schedule it there. So it's meant to start at time point 10. So that was an early start, original early start here. You can see it by this bar, shaded bar. That was the original schedule of this activity. You cannot do that because you're adding these resources. So you put X as long as you have this problem with maximum, reaching maximum resources, X, and this is the first point of time when you can load activity 7. Okay, you change timing of early start, you change timing of the late finish, and now your slack is not 0 anymore, but it is -1. So only when you do these changes on the bar chart, you will have these minus slacks, okay? They are indicators because you're doing it in progress. You're working in progress until you reach the end. And only when you reach the end, you have to create a new schedule. Your slack, it's not going to be minus, okay? Your slack is going to, you're going to make a new schedule, new end date. So your end date is not going to be 12 weeks, it's going to be 14 weeks. So you are going to make another network. That network can be quite disjointed. It can be looking completely different to previously simple AOM. And that's why we mentioned this managing critical chains. But that's beyond this lesson. That's for you to read an interesting research on critical chains. Okay, so what's happening here? Okay, that's the end result. So we converted this loading, like time-phased loading of our resources. Always think of time-phased. You're giving priorities and loading your resources in time by time. And that's your schedule because you loaded resources, and that is the only full schedule that you have. That is used in monitoring and controlling of your project. So what's happening now? Previously, you had the end date of 12. You had, remember, we identified 3 parts, and 1 was only a critical part. However, now you've got 3 critical parts, and you've got almost every activity that is a critical activity. So you can see how much we increase sensitivity of this project and why and how we made it more risky. But we had to do it because our resources were limited. So we had to give the best outcome with the situation we were dealing with. Okay, so outcomes. Now duration is 14 time units. We've got changes in all these start and finish times and slack times. We've got many more critical activities. Then we also reduce slack on that activity that's not a critical activity. And we've got an increase in critical parts. So lots of things that have happened, but they are necessary. And it's even more necessary for you to record it and to be aware of that, okay? To work with the real numbers, with the real situation, because I said at the beginning, planning is useful only as good input as you have, as a good quality. This is good quality baseline you have. Because later on, you can do monitoring and controlling and issue reports, but if you're not working with a good baseline, that is meaningless. So your reports and numbers are going to tell you different picture. And you will be saying, oh yeah, the project is deviating from the plan. No, you didn't plan well if you didn't do it properly with a good quality observation. So you have to record it, no matter how hurtful that is, how hard to accept. You have to accept reality. We have to deal with reality. You cannot put your head in the sand in a project. That's what many project managers do, putting their head in the sand, and they blame numbers. It's not numbers that are to blame. So all of this, it's hard. It's hard to do manually, like we did on a small examples. But we use softwares. Okay, again, softwares can do all of that, but you cannot trust software to manage it. You cannot trust all the data that comes out of a project. For example, you have to review risk. You have to review what software has done. Or actually, software can give you a possibility to split every single activity in a project, but you're not going to do that. So you are the one who has to examine condition, nature, risk, and many other things. You're working with a good basis. Softwares are very useful. I'm not saying they're not useful. You won't be able to manage nowadays projects without softwares, but you have to think and examine. You cannot just run by data that's the output of the software program. Okay, so what is the impact of resource constraint scheduling? It reduces delay. Okay, what does it mean reduces delay? When you have a limited number of resources and you're fighting over resources, then and you have this archaic order of priority that are fighting over limited resources, then you would experience delay. If you manage it properly and you apply this priority system on your resources by following a certain rule, then you will reduce this fighting and you will reduce delays because you can match perfectly available resources at the time and number with the activities and their priorities. Okay, so that's an optimization method to reduce delay, but at the same time, we are reducing flexibility. As we've seen, we increase the number of critical activities, increase the complexity, dependencies, increase number of critical parts. Also, when you load your resources, you can break the chain of the events. So your critical part, someone is moving the, yeah, okay, sorry. I didn't move the slides, they moved on its own, I'm not sure how. Okay, so you can break the sequence of events. And some activities can be hanging out, dangling, you know, they don't have any meaningful sequences. Chains can be broken. So again, we're talking about critical chain and not critical parts anymore. And we've seen at the very beginning on our wedding project example, some parallel activities now can become sequential because there is no other way. And that is also going to increase duration of our project. So splitting activities I mentioned a couple of times. So softwares have possibility to split every possible activity, but that's not something you would do as a project manager. You would do it on a very rare occasions where you are forced to do it and where the consequences and costs are not dire. It's not too costly and it's not too disruptive to do it. But remember, if you have a big piece of equipment that's expensive, that's hard to move, why would you split that activity? Remove that piece of equipment, not have it for some time, and then bring it back. That's expensive. You don't want to deal with that. So there is a cost associated with that. And you never split people's work when they're working on an activity, on their task. Remember, a task activity, it's the same, but we settled on activities on that term. But PMBOK identifies, equalizes that term. Okay, so when you're doing an activity, you don't interrupt the person. You're a project manager. You manage people. Okay, not CEO. You're a project manager, not HR department. And you assign that activity to a person. Don't stop it. There is always disturbance. There is always cost involved. You may not see it. You may say, let's say you're working in a matrix project environment and you are sharing your resources, and another project manager says, no, I need that person. I need it now. That's not my priority. You have to fight. You have to fight for that person and say, he is in that activity. I cannot give you that person until he finishes that activity. You cannot split it. If people are in the creative set of mind, they're in the creative process, and imagine what's going to happen. You're solving a mathematical problem, and in my experience, I've dealt with problems that I was solving for hours or days sometimes. And imagine when you stop that critical chain of thought and you go on to something else completely different. You stop that. It's very hard to go back into it. So that's a hidden cost. That's not a cost that you put a number on it, but it definitely exists, and you have to be aware of that. So every startup and every shutdown is disturbance in a project, and it costs money. When you have to do it, and when the cost is not huge, then you do it. But it's best to be avoided. So every time you split an activity, you add time that's necessary for the startup and setup and time and shutdown time as well. However, it's not only time that's increased, it's efficiency of doing that activity, executing activity. And the research shows that efficiency is increased 20 to 40% every time you stop an activity. So you've got the delays, you've got extension in time, you've got other problems like decreased efficiency. Okay, so far we've dealt with only one project. So loading resources on one project, a time constraint project, resource constraint project. We developed schedule for one project. We loaded this schedule for one project. But the reality is we've got many organizations with multiple projects, and usually these organizations, as they get more project mature, so that project maturity plays a very important factor of how you deal with certain issues and problems. You create a project office, and project office is in charge of dealing with multiple projects. So what about if so in one environment you don't look at projects in isolation because they share the common pool of resources. So what does that mean? If one project slips in schedule, it will most definitely affect another project because they are all linked. How are they linked? Through their resources. Also, if you don't manage properly like your resources, like we've seen in our first example with the botanical garden, if you have peaks and troughs and you don't care how many resources and where you have resources, that will multiply on multiple number of projects in your organization. So that problem will be expanded, exponentially will be expanded. So you have to manage and utilize your resources properly. And also, there are certain bottlenecks. So what are the bottlenecks? When you have a scarce resource, a resource that's not readily available, for example, a specialist, but you've got a highly sought specialist in a in a narrow field of specialization. you don't usually have more than one person that is like that. But he may be needed or she may be needed on many projects. So that's a scarce resource. That's a shortage. That's a critical resource. So you have one piece of equipment. Let's say you've got a testing lab and only one, but you have multiple projects that need testing. So they're fighting over these resources. So you have to manage, or project office manages multiple projects on a multi-scale. So everything you've learned so far on one project applies, okay? How do they do it? They can apply, for example, priority, first in, first out, like a register if you are a hardware engineer. You know what it is. So the first project that was scheduled and that started gets priority. That doesn't really assess priority and the nature of the project, and it doesn't assess risk properly. So it's not that system is rarely used. It's on some contracts where you have penalties associated with not finishing in time. Maybe you will apply this system, but probably not in isolation. So what you would do, you would centralize your management, and you will look at all your project as one big project. So you would look at it on a multi-scale, like a multi-project, and everything you've done with one, you will just apply on a multiple project by looking at it as one. And then you will get data. So you will see what can you utilize, what you can utilize, where you can assign resources, where you can't assign resources. So the output of this management will be distributed frequently to all project managers, so they have the info. So they don't have the info only on what's happening on their project. They have an info of the outside environment and what's happening around them, because that's impacting their performance as well. So this project office will issue reports, they'll issue recommendations, they'll work with project managers together, they'll sit all together and work out solution. What can be solution if you can't do anything else? You're dealing with a specialist that is only one and scarce resource in the organization. You might want to hire consultants. So consultants are hired on a short-time basis to deal with certain activities that require that input and that knowledge. For example, they cost a lot, but it's always cheaper, not always, but you have to assess it. In some cases, it's cheaper to pay that cost than to delay your project because you cannot get that scarce resource. Or also what you can do, you can outsource your part of your project. And more project organization reaches a higher level of project maturity, more and more they do that, because previously at the beginning of project management, people tend to do everything possible, but as they get more mature in project management, so doing more and more project management, you see they're actually very efficient at doing what is their core competence. And whatever is not their core competence, it takes time to evolve and to deliver, to actually develop, sorry, that's the word I was looking for, develop that core competence. And sometimes it's not feasible. Actually, many cases that's not feasible. So it's way better to outsource it. Yes, you pay more money to an outside company to deliver it. You're increasing your management interactions and communication, so that's a little bit more increased. However, it's probably cheaper that you give it to experts to do it than to develop that technology within your company. You cannot be expert for everything, and if you want to be an expert, you want to deliver everything, your project will last long time, it will cost huge money, and it might be even killed because you haven't considered this outsourcing properly, something that we talked over and over during your last project that has finished today, hopefully successfully. Okay, so when you're considering costs, and when Corey talked in week 5 about cost, you heard and learned about different types of cost, direct cost, overhead cost, administration cost, and that's something we're going to also repeat when we're when you're looking at reducing duration of a project, because reducing duration does have impact on cost. We look at direct cost. Project manager is in charge of a direct cost, but you have to overlay overhead cost and administrative cost to have the whole picture. But there is another view of cost. We can talk about committed, actual, and scheduled budget. Committed cost is something you cannot get out of. It's not necessarily spent money, but it's committed money. So you know you're going to be engaged in a contract. You know that you are going to hire equipment. For example, you schedule that crane far in advance, you sign the contract for that crane, and if you don't do it, you still have to pay money. Like, think about your booking for your holiday. You know, if you cancel well in advance, they might give you your money back. If you cancel 1 week in advance, they'll give you only 20% back. If you cancel 1 day, they'll keep all the money. So that's committed costs. Actual cost is actually what's happening in your project, how much you're paying. Your invoices and cash flows are raised, and you check all of that. Once again, you do it. Your managers on a project, and you as a project manager check all your cash flows. Because you know what's happening on a project, know your finance director, your finance department, you are the one who's doing that. And then you have a scheduled budget, and that's what we're going to talk about now, because remember when you had a WBS, the bottom of your WBS was a work package, and the work package is the list of all activities, and then for every activity you have to estimate labor costs, material costs, equipment costs. You add it all up in a work package, and you've got the cost of work package. Then you roll it all up. That's what we talked in chapter number 6. You roll it all up, and you get money needed for the project. Okay, but is that budget? No, it's not budget. Until when? Till we overlaid on a time scale, until we developed a time-phased budget. Okay, so only when we develop this time-phased budget, which is our budget baseline delivered in planning stage, only then we can compare in our monitoring stage. So lay budget over the time frame, unit by unit, and see how it is distributed and how that is done. It's simple, something you're very familiar with. Intersection of WBS, which is here, and OBS, which is on this side. OBS, it's got departments. Remember, we intersect at the lowest sub-deliverable level, not the work package level. Okay, this is the 100th time. And we intersect with OBS departments, not people. Okay, so OBS, when you deliver, you go down to all the people that are responsible for certain activities, but with intersection, you look at departments, because departments get allocated budget, not people. Departments are the ones that are in charge of that part of work, design work, for example, and they have to monitor it and control it. So this is our intersection. And what is intersection of WBS and OBS? It's a cost account or control account, as PMBOK calls it. Okay, and that's more appropriate term because that's the place where you execute control all over resources, money, time. So all of that is assessed at that point, at this point. So not only money, it's not only cost account, it's a control account. But now we're talking about cost. Okay, so in this intersection of the circuit board, we know the design department is going to do some work. Okay, and that's if you have a logical dependency. If one organization does work for that sub-deliverable, intersection will yield cost account. And this is a cost account. What is in it? It's a group of work packages. It can be one, or it can be more work packages, okay? And you accumulate them in this cost account. See here, you've got 2 work packages. One here, 150, and one here, 150. So the total cost of this allocated to this cost account is 300. Well, let's see this example, read, write, head. Okay, work that has to be done on this part, on this sub-deliverable. This is actually a product breakdown structure. So this product, production has to do some work. And intersection will give you this cost account. We can see we've got 3 work packages. One work package costs 130, assuming thousands. This one costs 40,000 and the third one costs 30,000. If you add them all together, that will give you 200,000. That's the money allocated to this cost account at the intersection of production and read, write, head. Okay, we're fine with that. Now, look at all cost accounts underneath one sub-deliverable. Okay, read and write head. You've got the first cost account with the section of design, value is 300. Intersection with production, value is 200. Intersection with test, value is 100. You add it all up vertically because everything belongs to this read and write head. 300 plus 200 plus 100 is 600. Okay, that's the value of this sub-deliverable, read and write head. The same thing you can do with horizontally for your departments to see how much money is going to be allocated to your departments. So let's see this production. We've got this cost account valued 200. This one is valued 50,000, sorry. And this one is valued 400,000. You add it all together, 400 plus 50 plus 200, it's 650K. That's going to be going to production department. So this is this value 650. So this is how we look at work packages, money, cost accounts, then allocation to a certain product and allocation to a certain cost account. However, we still don't have budget. We still don't have this time scale. So what do? We look at each individual work package. And remember, work package description, or how Pembo calls it, a dictionary. Why dictionary? Because everything is described there. So a dictionary work package description is given here. So deliverable that's related to the name of this work package, and then you have your activities. You remember that because that's something you've done in your project. And hopefully you didn't have testing, because there is no computer and software testing in a stage play, or hopefully you didn't have work package that Corey had as an example, because that was related to something else, something not related to a stage play. So you have to think meaningfully. What work package did you choose? Okay, that project is over. I'm sure you've done well. So for this prototype, PC prototype, you've got test work package, you've got activities, and okay, the total number, this is only labor. Obviously, you can have materials and equipment scheduled for every activity if there is materials and equipment for activity, but we're looking at labor cost only now. So the total labor cost is 120,000, but we have to schedule it in time. So we know that this activity lasts for 3 weeks. Look here, it's 3 weeks. That's duration of our activity. And the total cost is 120, but we have to do it in time. So in the first week, we've got 40,000, second week, 30,000, third week, 50,000. We split this budget, this cost in time for every activity. And then we pick up this data from WBS and Work Package Dictionary, we take it into schedule to get time phase budget. So this is our starting point for one work package. Actually, you start with individual activities, work package, you load it in the schedule, and how is that done? Let's see, okay? So this is the full work package with several activities. So previous example was one activity. This example was several activities. This activity lasts week 1, 2, and 3. Activity 2 is integration. It's starting at the week 3 and it lasts for 2 weeks. This is the spread of cost. You estimate that. There are certain rules in estimation. You can apply it for all activities for easier scheduling. You can use a rule. The most common rule is 50-50. You split it equally. But you can have 0 to 100. So you don't pay anything until that activity is completed. Or you can have 100 to 0. You pay everything up front because you have to do it. It's by contract like that, or some other conditions apply. Or you do a proper estimation of the work and money when it's needed, depending on the work that's delivered. So this is how you schedule your cost at the work package level. Okay, work package is in WBS, and then you roll it up. Okay, you have your network of activities. That's their dependency. You can transfer that network onto a time scale. You know how to do that. And in the first part of our lesson, we actually loaded resources on our time scale. We started with these activities that are vertically presented. This is the duration given, description, but now we don't have resources anymore. We have budget. So this is budget that's allocated for every activity in this network. And the spread of this budget is already done in the work package level because every activity is listed in one work package. Okay, so this spread is given to you. You just have to roll it up in this schedule. So activity 1, duration is 1. Fine, 1 time unit, budget is 5. You put 5. So you're scheduling your budget. You're scheduling your cost. Budget for activity 2 is 4. Duration is 2 time units. Okay? We know from the network when it's starting times are not given here, but you compare it with a network. Okay? So starting at the first time unit, finishing at the third. Okay, let's schedule our budget, our cost. Here, duration is 2, 2 and 2. 2 plus 2 gives the total budget of 4. Okay, 2 plus 2. How did we spread it? Equally here. So that's 50% rule. You will not have to decide how you schedule your budget because that depends on the nature of the project. It depends on the nature of the activity itself. It will be given to you. It's important that you know that this 4 total budget is spread in time for each activity. So you have to know this 2 plus 2 gives 4 here. That's the link you have to know. Okay, 3, activity 3, you know starting time, you know total budget. Here it's also spread equally in time. 2 plus 2 plus 2 gives 6. Okay, that's the total cost of this activity. Okay, activity 4. Well, it lasts for 5 time units. It's spread, it's allocated. A cost is allocated in time differently here. So we assign 2,000, so this is given in thousands, in the first week, okay? Then we don't pay anything. We don't pay anything here, and then we pay in the last one, we pay 1,000. So that is our spread. That is our schedule of cost for this activity. So you can see the 5th one, equal distribution. The 6th one, 2, 2, and 1. So 2 and 2 and 1 is 5. That's 5,000. This one is strange, really. It's probably depending on the nature. So 2, then nothing, then 4, then 2, then nothing, then 4. But it's important that all of this adds up to 12, and duration is 6 weeks. And the last one is 4 and 3. That's fine. Every single activity from the network, we used budget information, we used start time and end time. We used to schedule this budget in time to develop a time phase budget. But this is not all we have to do. Now we have to edit by weeks, by time units. So again, we're looking at 1 by 1. From 0 to 1, let's see how much do we have to pay. Okay, only 5,000, so you load 5 here. From time unit 1 to 2, you have 2 plus 2 plus 2. So now you're looking vertically, okay? And that will give you 6. Okay, let's look at something else. From 6 to 7, you've got 1 plus 2, that's 4, okay? So this is your weekly total. This is your distribution of the total budget by weeks for the whole duration of the project, which is 14. And then you have a cumulative budget. Okay, what does that mean? You're accumulating everything that you've paid so far, that you accumulated so far. So 5 is the start one, 5 plus 6. Okay, 5 plus 6 is 11. 11 plus 4 is 15. 15 plus 3 is 18. And in the end, what you're going to get, could you please tell me? So when you do this weekly total on the cumulative scale, what is going to be the end result? Yes, 52, yes, but what is that? 52,000. What is 52,000? Can someone tell me? Total budget, yes, that's the total budget for our project. But this is how it's delivered in time, how it's time phased. Where else can we read the total budget of our project? This is very important because next time you're going to do evaluation methods, so EVA analysis, and this is going to be your starting point. So when they tell you budget is that or find the budget, you can find it in this cumulative scale, or you can find it here. Okay, when you add up budget for all these activities, then you'll get the total budget. That's rolling up your budget by WBS. So that's the total money. This number here has to be the same as this number there. So you can see the placement is not does not have to be linear placement, like we had that example, 14 weeks divided by $40,000, and then in each week you were paying 3,333. That's the example from the very beginning. So it's not distributed like that. You have to estimate not just the work package cost or activity cost as a total. You have to estimate distribution of this cost on the time scale. Okay, and then you can monitor your monthly or weekly cash flow statement, especially if you get it from your contractors or from your departments that you're managing, people that are working on the project. That's something that you compare against your time scale budget, and then you see what's really happening and where the problems are, because this is divided by departments, by activities, by months. Okay, so it's given in time, and then you go to your time phase budget, and then you compare apples and apples. You cannot compare two numbers only. It has to be in relation to time and some other factors as well. But that's something you're going to talk about later. And also, when you load your resources on a time scale, then you can really monitor the usage of your resources. So only then you can have a clear picture. So this is given in time. This is given by departments, managers actually, and people, what they've done and how many hours they spend. So you can go back to your resource schedule and compare and see if that's appropriate management, if that's appropriate utilization, if that's something that you planned for. And okay, this is a little example. We are going to do a little example from your textbook, but then we are going to show some other problems, and we're going to launch into tutorials. So problems will be covered that are needed for your quiz, and this is probably the right time to make a little break. So I would say until 8:15 we can have a break, and then we can do some computational problems that they're not hard, but I'll still explain, and you may ask questions and you may interrupt me, and we can stop and repeat what needs repeating. Okay, so far we finished all the theory, we finished with the planning stage, we've got the master plan, and we can launch into monitoring and controlling. Okay, so now please take a break until 8:15. See you soon. Welcome back, everyone. We are now at the fun part. You all like solving problems. We're all engineers. So let's do some exercises. And you may interrupt me, Corey, and I can explain again if something is not clear. So we're not going to present it as a lecture model. So we are going to interact, and you can use your audio, you can use your video if you wish, or continue with the chat session. I don't mind. So this is a small little exercise that we are starting with. It's given in your textbook. I believe it's exercise number 9, and that's behind chapter 8. It's a small little one, but it's a good starting point. So you're given a time-phased work package and a network. What's a time-phased work package? That's a work package cost by week for 3 work packages. Actually, I would call them activities because they are presented in a network, and we know activities are given in a network. So we've got the total budget for the first one, design, is 4 plus 5 plus 2 is 11. Total budget for the second one is, if you add this all up, it's going to be 21, whatever, it's going to be K probably. So 11K, 21K, and here we've got 8Ks. But this distribution is what matters. Distribution is important. And here it's partially done network. So this is very common with exercises. You'll either be given information like we did last time in last week exercises, and then you have to develop your network. Then you have to identify all your critical parts and critical activities. And only then, when you have a network that you develop yourself from the information that you are given, then you can work with this cost schedule, time-phased work package schedule, and you can put it in here. Okay, so let's firstly deal with the network. This is just a sequence of 3 activities, so nothing complex. End time here is the beginning time here. This is duration, 3 plus 6, so you have to complete it. That's 9, and then you copy this 9 here. 9 plus 3 is 12. So this is the end of our of our project, and that's why on a time scale we've got 12 weeks. So this is our time scale, and this is our activities here. This is budget that is given, and now we have to roll this information on the time scale, looking at the network. What does that mean? Activity 1. It goes from time 0 to 3. This is distribution, so duration is 3. Distribution of the cost is given already. So you just roll it in a time phase budget. So copy 4, 5, 2. Duration is 3. So you did it for the first activity design. Second activity survey starts on a week 3 ending week 9. This is the budget distribution. So what you have to do, you just copy these numbers: 2, 2, 4, 4, 4, and 5. Okay, so you loaded that on the time scale to get a time phase budget. And then the last activity, it's only sequential, starting week 9, ending week 12. So it's going to start here. Total budget is 8, but this is distribution that we're looking at. So distribution is 3, 3, and 2. Okay, what is the next thing that we need to see? What is the next calculation? I'm asking you. So this is a time-phased budget. We time-phased budget for all these activities on the time scale, but we haven't finished. Total vertically, yes, to get the total, what's total cost for that particular week. Okay, so now we're going into weekly budgets. Great, Chihao. So 4, 5, 2, I'm doing it with a mouse, so that's why my handwriting is actually a mouse writing, and please don't mind these numbers. 3, 3, and 2. Okay. What's the first one? Even I can't read it. 4. Okay, and this one is 5. Okay, what's the next step we have to do? Asking you. Cumulative, yes. Okay, so we are adding it. Okay, so 4, copy here. 4 plus 5 is 9. 9 plus 2 is 11. 11 plus 2 is 13, etc., until you reach the total of what? Quickly, what's the total? Without adding up. Yes, it's 40. Why? Because we said it's already given here. So obviously you have to do it all the way to the end. And you have to check your calculation and your time phase budget in that way. So that's a reference point. But without looking, we don't need to continue, because why? We are looking by the end of week 9. Okay, the actual cost is 9K. So are we under budget, on budget, over budget? And that's the question for you now. On budget, Abdulaziz says on budget. Okay, how about, wait for me, okay? How about we run a poll, okay? And you've got 3 choices. First one is under budget, second one is budget, on budget, third one over budget, and it's anonymous, so we are not marking and looking who has responded what. We're just looking at your numbers. Come on, I want you all to quickly, not just 12 people, there is more here. Okay, so I'm not sure if I can move this. I don't think I can move it. That's an unfortunate thing, but you've seen it. Okay, so we were looking at the cumulative on the second week and the actual cost. So that's really what's happening on the project. Okay, we've got, okay, I'll close this poll. We've got majority going for the second option. That's 19 of you. That's on budget. One is saying over budget, and 2 of you are saying under budget, and quite a few of you are sleeping. Okay, so let's see how to wake you up. Yes, well, on budgets, by looking at these numbers, by you looking at a time phase budget, you would say yes, it is on budget, and you would be considering this cumulative cost, you are on budget. That is fine. That is correct answer. However, next week you are going to consider a few more factors, and this is just a little introduction. You scheduled in time to pay 9,000. And you're actually paying 9,000. So it's really quick to say we are on budget. But how about you plan to complete a certain percentage of work by that week? So we are in week 2. Do we have it here? Okay, we are in week 2. So only the first one is we're doing design. And by the end of week 2, see how much money we are actually committing by the end of week 2 for this one. But we really done only 30% of work, and we planned to do 70-80% of work. So the numbers are correct. So 9,000 is what we planned on that time scale, in that period of time. And the actual is 9,000. But we cannot say, are we under budget, over budget, or on budget, until we check how much work we have performed, how much we've really delivered. Because that can be a lot less than we planned, or it can be even more than we planned. In that case, we'll be under budget because we delivered more work than what we are paying for, or we delivered less work than what we are planning for, paying for. So that's a little introduction to your next week. And it can be handy. Next week is very important. It's a very powerful tool, Eva Analysis. It's used widely, and it's the only proper and correct way to manage and monitor and control your project. And for that, you need all these base points that we talked about today. Okay, so this is a little introduction, just a little sneak peek trailer into next week. So I'll stop this this, and I'll share. I'll share some files with you. Okay. There are a couple of examples that I'd like to go through with you, and all the examples are in the textbook. So the first one is the first problem that is in textbook. So this is how the problem reads. Given the network, and the network is actually in your textbook, but in exercise 1, it's partially completed network. So I'm not going to complete network for you. That's something for you to practice as much as possible. So compute early, late, and slack times, and what is the project duration, and so that's the thing that we're not going to do today, because that's something we covered last time. We're not going to go back. You have to practice that. And now listen to this. Using any approach you wish. For example, trial and error. So remember when I talked about rules of thumb and heuristics? It doesn't have to be always minimum slack, minimum duration, and then a minimum ID number. So that's the set of heuristics that we used. It can be something else given to you, or if it's a very simple project, it's a very simple example, you can really see what is the optimal one, not the closest to optimal that heuristics yields, but what is really the best and optimal duration or combination. Why? Because in some problems, you really have only few combinations that you run, and then you see exactly, yes, this is the best one. Considering resources, this is the shortest project duration we may have considering resources, okay? So not approximate, not rules of thumb, not heuristics, it's exact, because number of combinations are limited. So, okay, develop a loading chart for resources. Electrical engineers are described as EE, and mechanical engineers as ME. Assume only one of each resource is available. So there is a limit of resources. What happens if our resources are limited? Let's see what you learned from the lesson. Can anyone tell me, please? What usually happens if resources are limited? Anyone? I'll wait for your answer. I'll continue. Yes. Oh, yeah. Well, I've got Muhammad and actually Ali and Chihao. They're really switched on. Thank you, Sharil. Delay. Yes, you're right. Most probably, not necessarily, but most probably this will happen. So your limit in resources is that you've got only one available. So provide your resource schedule. So you have to have your network computed in your textbook, and then you do what your resource schedule. And then after you have a resource schedule, then you have to do your early start, late slack times of the project, because project changes. So you have to give new information considering this resource load. And which activities are now critical? What is the project duration now? Obviously, the question is, can it happen in real projects? Anything can happen in real projects. Nothing can surprise you, and you always learn on project. So it's a crisis that's happening every 5 minutes, and you have to deal with unknown. So it's not only that you're doing the first time project. A project is something that's done for the first time and only time, but you're dealing with new situations and new problems on a daily basis, on an hourly basis. So that's project management. That's the nature. Okay, so this is your solved network. So a partially solved network you've got in your textbook, and then you just keep going. You do forward pass, you do a backward pass, and then when you have this full network, you have to load your resources and you have to try. So first activity is using an electrical engineer, and remember, only one is available, both electrical and mechanical, only one of each. And this one is running in parallel. So you immediately see here we will have a problem. We will have a problem because both activities are running in parallel. We cannot schedule them in parallel. They will be sequential. And this one is fine because it's only one mechanical engineer and one activity that's using mechanical engineer. Okay, considering this network, it's really easy to load all possibilities. And that's why we said use trial and error. How do you do it? Oh, okay. Sorry, it's not on this one. It's on the other one. It's probably better if I share my entire screen, and then you will see everything. Okay, this is way better. Excellent. Okay, so I can even see your chat box, and I will see this. Great, excellent. Okay, so this is your task and this is your network. Let's not go to the end and let's not see solution. What I'm giving to you, I'm presenting all probabilities. It looks complex, but it's really simple. So, for example, it doesn't matter where you start. It only matters that you cover all possibilities and that you decide what is the best one. So start with mechanical engineer because that's easy. Mechanical engineer is the only one in parallel that's using mechanical engineer. So load, okay? Load it here. This is activity number 3. So that's why we're putting free. And this is by resources. This is a resource electrical engineer. This resource is a mechanical engineer. So activity 3 will be loaded for 3 weeks for mechanical engineer. Okay. Then you have 2 competing activities because they both use electrical engineer. One is available. I just decided to start with activity 2 because I know I'm going to cover all possibilities. And as you can see, there is only 4 available. So it's not complex. I load the second activity, duration is 4, so 2, 2, 2, and 2, and assign electrical engineer there. Now I have to look at dependencies, okay? So what comes, what I'll load after 2, obviously I have to load 1 because they were starting at time 0, so I cannot push it further in time. That's the next one to load. So 1 and 1 duration is 2. Duration you read here. What about mechanical engineer? What's the next mechanical engineer here? It can be either activity 6 or it can, it can be either activity 5 or it can be either activity 6. Okay, but activity 6 needs activity 2 to finish, and activity 5 needs activity 4 to finish. So we still haven't finished 4, So it's better to load 6, okay? Can 6 start at what point of time? It has to start at the 4th point of time, 4 time units after activity 2 is finished already. So now we have to have a little cross, little delay. Why? Because activity 2 has to finish, okay? So we have to consider this dependency. We cannot break it. And then we load 6 and 6, okay? Can we load activity 5? 4 has to finish. So not yet. Let's look at electrical engineers. After 1, it comes 4. So it has to be loaded. It's lasts only 1 day, so 4 is loaded. 5 comes only after 4. So it has to be one cross here, one little delay in using a mechanical engineer, and then you load 5. And all mechanical engineers are loaded, and the last one, 7, comes after 3. Is 3? Yeah, 3 is it's done a long time ago, so you don't have a problem to load it. You just load it after 4, so you're honoring this technological dependency and sequences, but you're actually loading your resources. And see what's the end of your project. So let's say we don't have a common date here, so it's 6, 9, and 7, so it will be 9 without loading resources. But here we are up to 13. Where's my pointer? Here. We are up to 13 weeks in this first combination. Okay, in the second combination, I decided, yes, 3 has to be loaded, no brainer. But now I decided to switch these activities for electrical engineers. So instead of 2, I'm loading 1 first. 1 lasts for 2 weeks, loading there, then next one has to be 2 because they started the same time. So it's either one or the other. Okay, so loading 2 here. Okay, but the next mechanical engineer is 6. That's activity 6 that's using mechanical engineer. What's the dependency? 6 is here, 2 is there. 2 has to finish before we start 6. And we push this 2 further in time. That means we will have to wait with this mechanical engineer for 3 time units because 2 has to finish before we start 6. Okay, put delay, 3 crosses for 3 time units, then load 6 for 2. And can we load 5? Not yet. We have to load 4 first. Okay, after 2, we have to load 4. 4 is asked for 1. 1 is finished, so you can load 4. Now this is fulfilled, so we can continue with 5. Okay, and this has pushed the end of the project to 14. You can see if you load 1 and 4 first, they're using electrical engineer, and then you load 2, then this possibility will give you project duration of 11, and this is the last possibility, project duration of 17. I'm not going to go through all of them. This will be posted. You can review it. The answers will be posted on our model site, so you can go one by one and examine, but there is not really a lot to think about. This is all possibility exhausted because it's a very simple network, and just looking at all possibilities, you know exactly what is duration of your project. So this is the solution. If you see immediately what is the best solution, you don't have to develop all these 4 possibilities, or 3 or 2. I don't know how many there might be in your problem. In this particular problem, there were 4 possibilities, and I've ran them all, and I found the best one, which is the one that is given here. Okay, and now we have to see what is happening with our times. Obviously, slack is 0 for all these activities, because we have to give priority to resources. It's not only activities. Okay, so 6 comes after 2, okay, 2 is finished and 6 is starting here. But still, it doesn't mean that we will have a slack for activity 2. See, slack is 0. Why? Why is slack for activity 2 0, even though 6 is starting on in a week 10? Because we consider resource dependencies. 6 cannot start before 5 is finished as well, not just 2. So this is 2 and 6 is only technological and logical dependency, while 5 and 6 is a resource dependency and resource constraint. They use the same mechanical engineer. So that's why we have 0 slack everywhere. And you might even do a network that looks different, but we're not going to ask for that because networks can look very, very weird, very disjointed. So what is important for you to know is how to give us the best possible duration, loading your resources, whether it's a trial and error, whether it's running all combinations that can be very limited in number, or we will give you certain heuristics, and then you'll see how what's the probably the best option. Heuristics, it's probable best outcome, not definite best outcome. So we can see that previously it was 9 days duration, but now it's been extended to 11 days, and all activities are critical because they all have 0 slack. Because of resource shortages. Obviously, they are very present in the project. So this solution will be given to you attached. You can review it before when practicing for your quiz problems. So do not worry about that. Okay, so now. Okay, so solution is already given here. I just want to have 2 parallel screens so you can compare your network. You always have to work with your network when you do your resource scheduling. Now it's a problem number 4 from your textbook. Okay, now we have to prepare a schedule for a project where a tractor is a resource, and it's a type of machinery as well. I don't have a nice little picture of a tractor, but it doesn't matter. So there are 3 tractors available for the project. So that's our resource limit. You can immediately see from the description, is it time constrained or is it resource constrained project? So 3 tractors are available. Okay, so activities or resources are usually given in a network. Okay, activity A is using 1, activity B is using 2, 2, 1, 2, 2. Fine, you've got a network, you've got logical dependencies, and now you have to develop your resource schedule. So you're loading these resources on the time scale, and you are developing your resource schedule. Okay, so all this data is just let me see. Okay, maybe it can be zoomed further. Yeah, okay, that's probably better if we extend it even further. So give me a second. Okay, you can probably see this a little bit better. Okay, so having a look at the network, we are developing a resource schedule. But what do we need for that? In order to assign priorities, you need to know your you need to know the heuristics, and the set of heuristics is given. So that is minimum slack, smallest duration, lowest ID number. Okay, fine. 1 and 2. So what they're running in parallel, maximum number of tractors is 3, so that's fine. We can load them, not a problem, because we're not exceeding the maximum number. Load 1, load 2, okay, for the duration. Duration is given here, 5 and 4. This is the number of resources, and we still have slack. this dark shaded box is the Slack for activity A. Okay, let's examine period 4 to 5. We have loaded B, that's using 2. Okay, let's see, what's the first rule? First rule is to load activity with the minimum slack. What is that? 2, 0, 2. We obviously load this one because slack is 0. Let's check how many resources it's using. It's using 1. If we add 1 here, we are not going to be over limit, so that is fine. We can load D. D is using 1, it's lasting for 5 units, that's fine. It still has this slack because we haven't moved it in time. But everything else that is parallel, we cannot schedule. We cannot give priority because we are already exceeding the maximum number of resources. So we push E. Oh, sorry. Okay, now this one I haven't done as well. Okay, so this is the first one that is to be scheduled. Sorry, and now we have to schedule the second one. We are looking at C and we are looking at E. The first rule is minimum slack. Slack is 2 for C. Slack is 2 for E. So that's the same. What do we do then? We move to the next set of rules. So that's the smallest duration. Okay, something is not correct here. And that is, let me just check everything. So smallest duration, okay, it's using 2 and 2. Okay, it should be E that is loaded first. Is that correct, Corey? This is the direct answer from the textbook, and obviously it is something wrong. So going by the rule, smallest duration, 3 for activity E and 4 for activity C. Okay, what they did, I am assuming, why did they make this mistake? Because activity C is starting at the time point 4, while activity 5 is starting at the time point 5. So we are looking here what comes first. So that's activity C. So they're not strictly all in parallel. So activity C still starts earlier. It was pushed a little bit by 1. Oh, yes, okay, I see it now. Okay, so activity C is in the time frame 4 to 5. Okay, we have to push it further from, it cannot start at 4 because 2 is already here. We cannot assign 2 there because it's going over our limit. The one thing what we didn't do, and that's why I advised you during the lecture time that you have to do all the time, otherwise you get stuck, and that's the same thing that happened to me. What we didn't do, when I added this X, I didn't reduce slack for the activity C. Okay, so the first time I added this X for the activity C, slack is not 2, it's actually 2 minus 1, it's 1. I cannot use unfortunately the pen here to make crosses, and that's why I made a mistake. Okay, that's why I was really confused. So slack for C is 1 now because we put this cross here, and slack for E is 2. So what's got the smallest minimum slack? It's activity C. And that's why we loaded here. So now you've seen a perfect example why every time when you put crosses, you have to change your start time, finish time, and slack. I didn't have a pen in here to do it, so that's why there was a confusion. So load C. Okay, 2 is loaded for 4, and then we load this D, and we exceeded, we actually at the maximum of our resourcing 3. So that means we cannot schedule E. As long as we have this total number of 3, we cannot schedule this activity E. what's the first point of time we do? We do it here, but don't forget, we put 4 X's. So can we schedule it here? No. Can we schedule it here? No. 4 X's. Every time you do X, you do what? Change. Early start is not 5. It's 5 plus 4. It's 9. Early finish is not 8. It's 8 plus 4. It's 12. Slack. It's not 2. It's 2 minus 4. So it's minus 2. So please do not forget to change your numbers every time you put a cross in the box. And then you load activity E at the first available place. That's time unit 9. 5 plus 4 is 9 because we pushed it 5 time units. Load E. Okay, great. F is supposed to start at 10 time units. Let's look at 10 time units. Can we do 2 here because F is using 2 tractors? No, we cannot, because 2 plus 2 will be 4. That's more than 3. That's maximum available. So we have to push it. 2 crosses, 2 time units, changing the slack. So slack is not 0, it's minus 2. And that immediately tells us that the project will be extended by 2 time units. So the finishing time is not 12 anymore. It's actually finishing at 14 time units. So you've seen an example. This is all described to you step by step how it is done. So okay, that is the next one. So everything is described step by step how it's done and how you change it. You can change it here on the table, but it's much easier to do little crosses and to change the numbers directly on the schedule. This is the resource loaded schedule, like we did in the lecture. And do not make that mistake, because you can easily get confused and you can really wonder why this and not that one, and you can make mistakes. So this is a perfect example. So do you have any questions now on this resource loading schedule? Because we can quickly go over time phase budget. Very important for your next chapter and for the problems from EVA analysis. Okay, but any problems with resource time phased schedule? So simple. Still understand why we choose C instead of E? Okay, because you go time unit by time unit. After you finish 3 to 4, the next one is to 5. What is the activity that is between 4 and 5? The only one is activity C, because D is starting at 5 time units, E is starting at 5 time units. So we are only considering C in here, 4 to 5, okay? What do we have already loaded? We have activity B loaded, 2. Let's examine C, okay? C is 2. 2 plus 2 would be 4. We have to push it in time, we put cross. If we put cross here, we reduce slack. Slack is not 2 anymore, it's 1, 2 minus 1. So when we compare slack, this minimum slack rule given in our heuristics, then C would have slack 1 and E has got a slack 2. So we load C first, okay? Yeah, obviously you go, starting time is critical. Yes, why? Because you go unit by unit. You don't look at all units at the same time. You do it time by time. Be diligent, because a little mistake can go unnoticed, and then you make a mistake on the whole schedule. Fantastic. Still, anyone that didn't understand this or something else, I will. That's not a problem. I will repeat it. This is tutorial, so we go as long as you don't understand. I'm here to answer. Okay, you think about the questions. I'll quickly go through some samples of time phase budget. Okay, this is only for you to get familiar. Why? Because you need to quickly read. You need to quickly learn how to use this data, because this problem is not going to be given to you on its own. It's going to be used in your EVA analysis, and that's why I insist on this time phase budget. So previously we covered resource loading schedule, and now this is a time phase budget. So this is only for you to examine, let's say, what's happening at the end of week 4. You have to know that you add this cumulative 2 plus 2, it's 4 here for this week, 3 to 4, and this is a cumulative for the project. And the only thing I want to repeat at the end, we've got the budget for the project, and this budget can be read here. These are important things for you to continue with EVA analysis, to know how to read time phase budget, and that's why I've given you another example. Okay, Yiligong, why the slack of C didn't change to -2 in the table? Okay, you change slack only how many X's do you have? So you originally had a slack of 2, but you had to push this activity only 1 time unit. That's why I had 1 cross. If you used 1 out of 2 available, so you could have pushed this one 2 in total and still be on time, but you pushed only 1, so you used 1 out of 2. 2 minus 1 that you used, it's 1 now. Okay? Is that the question that you ask? Is that the answer that you wanted? So again, you do it unit by unit, time unit by time unit. Don't jump. From 4 to 5, there is only 1 eligible activity. That's activity C. D and E are not eligible to start at that point of time. So that's why you consider only C. Okay, so this is only for you to look at, to play how to have budget per week, how to have cumulative budget, how this is the same and this is the same, and that's your reference point or checking point. And now there's one little task, the last task that we're going to do. So we are going to use the network, and we are going to use to develop a time phase budget. What do we need for that? Previously we had resources per activity, and now we have cost by week. So activity is costed per week. We've got the total cost, but we also have a distribution of cost per week. So the total budget, how do we put these two information together? Your network, so your activities in time and their logical dependency, and this budget per activity that's spread in time. Okay, that's easy. Activity A is starting time 0, lasts for 4 time units, and this is the spread of cost. So use this information and load it in your schedule. From 0 to 4, you load 10, 10, 10, and 10. So you copy this. Obviously, it has to match. Duration 4 weeks, spread of cost by 4 weeks, you load it here. Activity B starts at 0, lasts for 5 weeks. This is the spread of cost. So from 0 to 5, you will copy this given spread of cost. Again, you're not going to be asked to estimate by weeks because you don't know the nature of the project. Some information has to be given to you. For example, plan value is always, like a budget is always going to be given to you, or you can read it from somewhere. So that's why I insist that you know how to read it. Okay, what's the next one? 4. Okay, 4 is the next one because these are 5s. C starts at 4, finishes at 8. What's the spread of cost? It's given here. So just enter it. C is there from 4 to 8, enter the cost. Next ones are D and E, both starting at 5. Okay, we copy this cost for 62226 here, 6226. we copied for E. Okay, so it's following the time. Where do you read time? You read it from the network. Where do you read the spread of cost in time? You read it in the cost by week. So that's a separate table. So you actually join these two to create this time phase budget. Okay, what's the last one? F. F is 20 and 20. Starting point is 10. Okay, so 10, we put it here, 10. End point is 12. That's the end point. That's the finish of our project. Duration is 2, 20 and 20. Great. Here we've done total budget. How do we get total budget? You add up all these costs. So in this instance, it's not given to you. You have to do it yourself. But that's easy. 10 plus 10 plus 10 plus 10, you'll get the total budget for activity A is 40. You do this addition for every activity. You sum it up together. That's going to be the total cost for your project. Okay, first calculation done. Then you go week by week, diligently. Do not skip. Do it vertically. Accumulation. 10 plus 8 is 18. 10 plus 4 is 14, etc. 20 plus 20, sorry, this is only 20. So the total for this week, 11 to 12, is 20, but only that week. So we've done this step, and now the last step is cumulative. You're adding all weeks together, 1 plus 2, 1 plus 2 plus 3, 1, 2 plus 4, okay? You get the cumulative. In the end, you get a total budget for your project. This has to be the same as here, or adding this all up will has to be 206. So your reference points. This looks very easy, very easy to understand to do, but many students, when they get more, you're not going to get this problem. You're going to get a more elaborate problem after finishing next week lecture, but you are going to use this time phase budget. So if you don't know what's a time phase budget, how it's developed, how is it used, what does it mean, each part in this budget, then you will not be able to solve these complex problems that we are going to have after finishing chapter 13. Yes, cost by week has to be said provided, because you don't know that. So either it's going to be given already in a schedule to you, or it's going to be given like that, and then you develop a schedule. So this data from the project, raw data from the project, are going to be given to you, whether it's a planned value, whether I'm talking some terminology that you're going to hear about still. But remember it, because it's coming next week and it's really important. So if you don't know how to read the time phase budget, you are not going to be able to solve multiple problems, because that's the starting point. The same thing with AON network. If you don't understand that, if you don't know how to do it, you're not stuck only on one question and one problem. You're stuck with a lot more, because a lot more things will depend on your network, on how you do forward pass, backward pass, critical paths, slacks, and everything else. So doing the simple things, but all these simple things are going to join into complex things, and they're going to be linked. So that's why make sure that you understand it, and don't consider it too easy, because it's easy to make mistake. I made mistake because I didn't have a pen to use. I was planning to use a pen, but here I can't. And it slipped. I just didn't see it because I didn't note it. Otherwise, I would note it diligently. So be diligent, because it's easy to make mistake. Okay, we are finishing with this tutorial. This will be given to you. Post it. You can practice. There are other problems in your textbook. But now, do you have any questions, whether it's a resource loading schedule or whether it's a time phase budget? So any questions? if you need to go, you can go. You're free to go. I've finished everything, but I'm still here until the very last question is answered. So do not be shy. There is no wrong questions. There can be only wrong answers given. We are here to learn. I always repeat that. We're at your disposal to teach you. Okay. I will wait. I'll be the last man standing. I'll wait for your questions, but for those that that have been with us tonight, I wish to thank you for your time, for your attendance, for participation, for your answers. I know many of you will watch recordings, especially because you will use this in your quiz questions. So some of you will come later to these lectures, but it's easy. You can organize your time. So thank you all for participating. It's been a great pleasure to teach you and explain. I'm just waiting for questions now. Thank you all. Whatever you don't understand, it's really not a problem to repeat. I can go over whether it's a lecture, whether it's a problem. If you don't understand, I can try to explain in another way. That's what I usually. Thank you, Corey, for your time, for monitoring the chat and answering some doubts and questions while I was lecturing. So it's always great to work together with Corey. Okay, I don't think there is anything that's left unexplained. So if you think of anything else when you watch again or when you try to solve a problem, please send me an email and I'll explain whatever you don't understand. That's not a problem. So you don't know what you don't know unless you do it yourself. That's usually the rule that applies to all of us. Okay, there was, okay. We passed 9 p.m. and this session is going to end very soon, so I'll stop recording now.